From a recycling efficiency perspective, right? I'm sure different form factors as well as applications. Like, what are some of the high level points that would affect the recycling efficiency? Let's say, for example, there are two 18650 cells which are the same sort of say energy cells or power cells. Okay, they have the exact same specs, but one is being used in a vehicle, the other one was used in some sort of a stationary application maybe. Both have come to you at the same health. How like, this is just one thing, right? I mean, you're the expert. What are some of the things that will affect recycling efficiency, and what is the efficiency usually?
Okay. So first we will talk about in India majorly you have a lot of geometry wise there is difference in geometry wise, then there is difference in chemistry wise, and third there is a difference in the capacity wise, right, the material. So that means right now majorly right now in India we have a prismatic cell, we have a pouch cell, we have a 18650, we have a 21650, we have a 27700, we have a 32770, and then followed by several prismatic packs which ranging from 230 watt hour to even maybe 20 watt hour. So that is the whole variance is there in the country. So it's very hard to process in the same pilot line, right? The problem is that the process which you have created, there is there are a lot of size, because 18650 is different size, then your 3265 is a different size, even the sizes, and then you have orientation also, the short and the geometry. So now the problem is that when once you have received the battery, you have to short a different kind of battery in alone. That means the 18650 you have to separate as a different section. Your 32650 you have to separate as a different section, and then you have a prismatic ones. And regarding this also, you have a maybe in pouch cell you will got LCO, mainly pouch cell you have a LCO battery, lithium cobalt oxide, mainly in the mobile phones which you are having. So they are basically contains lithium cobalt metal oxide material inside it. So that battery can be placed in one segment, and then you have a 18650 which you major laptops, if you see about laptops and power banks, they consist of 18650 batteries. So their volumes are right now, if you compare the volumes of your 18650, even large if you compare with the other vehicles, because if you talk about 32650, it is recently, I think it is 1 2 years down the line. So still in the market, the major bulkiness, major volumes which are there, that is your pouch cells and 18650 cells. If you talk about right now, second point is that once the battery is being reduced, we have a different processes. Let's suppose if you are having your pouch cell that doesn't contain any steel, right? So the mechanical point of view, if you want to process the cell, so pouch cell you have to process in the different sector, the 18650 you have to process in the different line, because that consists of a steel material that is hard to recycle. But yeah, now what we are doing is we have made a modular system, that is the modular system of the plant. That means shredders you are using two, but down the line you are using same equipments, because once the materials they are containing the same, right, the chemistry they are using the same. And even in the third part, the structure inside the battery, you are having anode, cathode, and a separator, right? So that means after shredding the process is same. So we have made a modular system, we have made a chemistry agnostic system. That means whatever the chemistry you are having, you can process in the same pilot line, because it reduces your OPEX and CAPEX while you are running in the plant, right? Because it is very much important to reduce your OPEX and CAPEX to recover these materials. So right now, the thing is that for prismatic, we have some problem to recycle it, because these are bigger packs, maybe if, the EVs which they are using the packs. So for that we have having a different line, because the packs are bigger, and even you have to discharge fully, because they consist of high density energy inside the battery packs. So you need to discharge them very, this is a very what we call very critical process to discharge it. You cannot discharge each cell separately. It is a time consuming process. So what we are doing is, we have for electric vehicle batteries, we have a nitrogen based shredders. That means the whole shredding is being done into the what we call the inert gas involvement, so that there won't be any firing or explosion process. Third part is that we have some of the problems in 18650, because right now in India, if you see, we have LCO batteries, LMO batteries, NMC 111, NMC 532, then you have NMC 632, NMC 811, and then you have NCA. So these 7, 8 chemistries you will find in the 18650 batteries. So you can understand the variability in the chemistry inside the same cell, which is having same structure, same same cell form factor. Now the thing is that our you should make a process where that each cell, because the major thing is the testing, right? India don't have right now a proper testing facility, especially for the destructive testing. We can do a non-destructive testing where you can measure a sort of parameters, maybe the voltage or whatever the thing is. But you need to test the material which is inside the battery, and for a bulk you cannot trace the material, because this is the profit. Ultimately whatever you are processing, that should make some profit to to make whether it's OEM or whether you make a franchise model. That model can be only sustained when you should have some margins on and profits on it. So now what the challenges which we are facing, once the battery is being received, we don't know what is the material inside the battery. Right. So right now we are into the process where we are checking the 5% of the total battery, and that happens on the total, you need a huge laboratory. More onto the pilot plant, you need a laboratory first, because each and every cell material should be tested before going into the plant. Right. Well, let's suppose you are having a lot of around 1 ton. So you should know about of that 1 ton, what is the material inside the battery, whether the manganese is there, whether the cobalt is there, and what is the material composition of that battery. So this is the major key challenge right now, to test the chemistry of the cell and the test the material which is inside the cell. That means the destructive testing is very much necessary, and for the destructive testing you should have a completely laboratory setup in terms of testing and calibration, as well as the characterization. So that whole process should be done into a one to, and that needs a huge infrastructure cost to maintain that. And the reason why it is not happening is because we don't manufacture the cells. So that means you don't have a technology, you don't have a process, you don't have a manpower expertise on it. Right now we should do work onto the creating a manpower expertise onto this sector. Even right now in India we don't have a much power, expertise onto. You cannot get a manpower expertise. So what we are doing, we are developing first the expertise onto this technology, because you need huge people to test it. You need a huge expertise to, we are creating a process of testing the material, because in this the major machinery which we need is the inductive coupled plasma mass spectroscopy, right? So the whole scenario, the conclusion which we want to make is that is something, the testing part, the laboratory part, and the technology on the basis of material testing. So material testing should be done in a very quick and affordable manner, so that the before putting into the plant you should know about the chemistry of the cell, because physically you cannot know what is the material. Physically you cannot even predict what is the material inside the cell. So this is the major challenge. Even for this EV vehicles especially, they are using, I think, NMC. Some of the companies is using NMC, and major now the company is shifting to the LFP battery because of cost, safety, as well as majorly the cost part. And even the assembly is a little bit easier, as well as the thermal, because of the thermal, because in LFP you are getting thermal the heat which is liberated by the battery, that is somewhat lesser than the NMC. Yeah, little bit, if you say the energy density is lesser, but the thing is that when you are going to shred the EV battery, so EV battery should be handled very much prominent, because what you are doing is they are having a larger pack. So before putting into a shredder, you need to be discharged fully. And even before that, I think whatever our testing, what we have done, major batteries of four-wheelers we can utilize in the second life. So that is the whole point of the major which we are suggesting is that the laboratory and the testing equipments and the process, as well as the manpower expertise should be created to run that facility.